Okay, on this new set, I did not get through to start on it. I am going to ask us to look at this first one here. As I was marking the first set of worksheet, I already noticed that some of you are making lots of mistakes already, which is odd because all of you were sounding very confident about it. So I feel that it's about doing things in a haste, like what Amira is doing now. I didn't say start doing it. You already started doing it. I'm glad you feel excited about it and feel that it's easy, that's why you want to do it. But at the same time, I want you to be aware that there's no competition for rushing to finish. And most of the time when you're hurrying to do it or complete it, you miss out important bits and you make careless mistakes. Okay? Now, here, this is on the first page here of the new set, you get page 169. Here's the most important information. It says here, number one, equivalent ratios. Actually, for how I've arranged the sets that we have been doing, I've been introducing the equivalent ratios ideas right from the start when I introduced ratios to you already. Now, the important part is here. The most important, in fact, is this term called equal grouping. And that's why we were able to use models to help us solve the word problems, because model drawing requires on the most important part, there's units. And you realize that equal grouping is happening such that you can have equivalent ratios and there's this simplest form. So when we learn about equivalent ratios, we can think about why we know, why it feels easy is because we learned equivalent fractions before. So like half is equals to 2/4 and equals to 4/8. We are able to do this because they are common factors. The same idea is used in equivalent ratio. Now, the most important thing is trying to tell you that no matter how I look at these ratios, they all goes back to equal grouping. So in this case, for the example here, by right, there are 3 squares, 3 squares, and 6 circles. But because I could make equal groups, group them up in equal groups, I can simplify it to 1:2. It comes with the idea of equal grouping. Now, this is the concept behind it. Once we are familiar with it, you are able to solve the questions on the next few pages, like for example, this one, without thinking much. By using the idea of the equivalent fractions, and the most important thing, how good my times table is, I'm able to solve this. So if let's say my times table is not so good, I skip to page 171. If my times table is not so good, I will realize that I may take more than one step. Are you writing? Oh, wait. So I may take more than one step. I may go to 16:4 is 8:2, and 8:2 can be simplified to 4:1. But if my times table is good, I don't have to go divide by 2, divide by 2, divide by 2. I just start thinking of the bigger numbers first. I can divide by 4 straight away to give me 4:1. Now for this At this stage on this page 171 onwards, is really a challenge of how good is a times table. So in your times table that you need to memorize, what's the biggest possible number? In a times table that you memorize. You have the 1 times table, 0 times. Anybody have trouble with 0 times table? No problem, right? Anything times 0 is 0. Anything times nothing is nothing. Anybody have problem with 1 times table? No. Any number times 1 will just be the number, correct? Also no problem. Anybody with 2 times table difficulty? Also no, quite easy. 2, 4, 6, 8, 10, no problem. Okay, so 0 times table, 1 times table, 2 times table, 3 times table, okay? 4, okay? 5 easy? 6, okay? A bit hard. 7, getting tricky. 8, yes. 9, 10, 10 super easy. Just add a 0 at the back, is it? Okay, how about 11? Easy. 11 times 3? 11 times 4? 11 times 5? Why so easy? Yeah, so the pattern for 11 times table is super easy. How about 12? Very big one. Okay, but I think up to 11 is very good already. So, guys, usually I'm going to say this once. Hear it. Don't do anything. Hear it first. Oh, wait. There's a very common practice among many teachers, many tuition teachers, many people who try to teach equivalent fractions and equivalent ratios and telling you how to simplify it by trying out the times table according to upwards. So the teacher will usually tell you to do divide by 2, divide cannot divide by 2, you try divide by 3. Cannot divide by 3, divide by 4, see whether can or not to do simplification. Understand what I'm saying? Now I'm trying to tell you something different. Take on this challenge. Instead of thinking of instead of going divide by 2, divide by 3, divide by 4, I want you to try divide by the biggest possible number first. Like for example, in this case, 16 divided by 4, just look at 4, can I divide by 4? So I have 7 to 21. Instead of asking you to take divide by 3, can I just divide by 7? What we get? So the method is the same as equivalent fractions. It's equal grouping. So I divide both sides of the ratio with the same factor. Because I'm grouping them the same way, so 1 is to 3. Now, let's say the next one, C. 24 to 64. Many a times someone, whoever, may tell you, or last, when I introduce equivalent fractions to you, I also tell you, let's try divide by 2 first, divide by 4. Now, let's go with the largest number. Now, 12 is a bit hard. So let's don't do 12. How about 10? Can divide by 10? No, is it good? So some says 8. Okay, so you think you can do 24? Can you divide 64 by 24 easily? Because 24, you divide by, I find this even challenging to do long division. I won't divide by 24 immediately. But if I have to do 24 times 2 is 48, times 3 will be already 72, which is way off. So I won't go 24, that's too greedy. Remember I said, try to go with the times table. 12, not so good idea. 11 is not so good idea. 10 is not working. 9 won't be working. Why would 9 not work? Yeah, because they are even numbers. Go with 8. 24 divided by 8 is 3. 64 divided by 8, 8. Is this the simplest already? Divide by 3? No, not possible. Now, 45 is to 27. Usually, your teachers will say divide by 3. Let's go with the big numbers, as big as possible. Divide by 9. Is this good? 37 divided by 9, that's 3. 45 divided by 9, 5. Can I divide by 3 further? No, that's simplest form. Is this okay? So, I want you to change the way you think. Instead of dividing by the smaller numbers first, try going with the bigger number. So 54 is to 81. Instead of dividing by 2, 3, 4, go with the bigger numbers. And then your friends can say divide by 9. So 81 divided by 9 is 9. 54 divided by 9, 6 to 9. Can I divide further? Can I divide by 6? No. Divide by 3. So I get 2 is to 3. Is this simplest already? Yep. If I do, so the thing is I can do divide by 3, but it will be multiple steps. So I will choose to go by dividing by the bigger numbers. Is that okay? Now, so 771 here is the homework. Finish up the last question. And then 172 as well is homework. Now, skip this. Don't have to do 173. This is for tomorrow. I'll be doing this in class. And 174 is for tomorrow in class. You don't have to do it. Okay? Now, I repeat again. Let's go to the front again. I'm right at the front, 169. So this one is homework as well. The key idea is, I find the easiest way to group this. I make equal groupings out of this. So instead of 6 triangles to 4 squares, I can go 3 to 2. I'm on page 169. Is it too fast for you? Our boys in the homework club today, remember, is going on. Write down. Hold on, wait. 169. I'm circling it. I'm telling you the homework now. 169, 170, 171, 172. Homework. Is that clear? So from 169 to 172. Okay? Okay? Now those of you who are ready, you may go for your done lesson.